server-side rendering with Angular. And if you know me, you know that I like to start from scratch on everything I cover. So we're going to start from the basics and go deeper and deeper and explore really what happens when we do SSR with Angular, what are different options, and yeah, see why it would make sense to do that. So my name is Alain, and sometimes I even simplify it as just Al, because I know people struggle with my name, so Al is fine. I'm a GD in Angular and Google Maps, and I've been working with Angular and Angular JS before that for way too long. Started back in 2011, so it was even before Angular JS was officially released, so that's crazy. Makes me feel old now. So I'm a consultant and technical trainer at Angular Training, which is my company, and we sponsor ng-conf as well. So yeah, speaking about Angular, teaching Angular concepts, TypeScript, JavaScript, Cypress, even a little bit of React is what I've been doing for a very long time now. And yeah, I speak at conferences all around the world. So that's me. Now, the goal for this hour that we're going to spend together is to be kind of like a small workshop, in a sense that if you want to practice and do these things, you'll have the opportunity to do so. Now, SSR is tricky, right, to do as a workshop, because server, client, all of that stuff. So I prepared some code repo that we can use, and you'll have access to that. And the app we're going to work on is this one. So store.angulartraining.com, which is a very basic app, like kind of e-commerce kind of thing, with a list of products, and there's a cart, there's a checkout page. So just a few different pages, just a couple of HTTP requests, just the basics we need to do something meaningful. And I mentioned we're going to do it as a workshop. So if you want to get the code and the instructions to get started, you can go to that URL. So bit.ly/at-ssr-repo. And that way you can get started, because I know the Wi-Fi can be a little bit overwhelmed. So if you want to take a 2 or 3 minute head start on that, feel free to use that link, and you'll get there. So there's a lot of talk about server-side rendering these days. And I want to start with the why. Why would we do that? Why would we do server-side rendering, and how it helps? So it's important to remember what happens when we use Angular, regular Angular, right? Regular client-side Angular. The idea is that you type a URL in your browser, it's going to send a request to a server, the server downloads your HTML page, which is pretty much empty at this point, right? Just the app shell, and the page is going to download JavaScript and CSS and all of that stuff. And then the browser has to parse your JavaScript. It has to parse that JavaScript, interpret it, and once this is done, it can start building your app, building your DOM structure, displaying your components and everything. And I make it sound very slow on purpose. It may seem pretty fast most of the time, but all of that has to happen before we get our components rendered on the screen. And of course, once the DOM is built, our components most likely are going to trigger HTTP requests and do all of their stuff to get data, and then even keep building more DOM, displaying different components and such. And once you've done all of that, you're at the point where your page is fully rendered. So we get the green check mark, we're all good, everything's rendered. So it can take some time, because some apps have more JavaScript than others, and you have to download all of this upfront before your application runs. So if you build a regular Angular app right now using ng-build, your output, what you'll get in the dist folder, is an index.html that looks very much like this, where all you have really in terms of HTML is the app root. So one single element, right? And then you have all of the scripts that make the magic happen and Angular display your components. So that's really all we download when we use regular Angular. And while this can be pretty fast, it can also impact performance in many ways. So this store that I showed you, the performance measurement that I got from Lighthouse was 85. And the goal is that by the end of this talk, we'll be close to 100. We'll see if SSR can help with that. So let's give it a shot. The first thing we're going to do is build a project, display it in a browser, and measure performance. So simple things. You can go to that URL if you want to get the code and see the instructions how to do that. Then we just run a build. We get the build output. And once we have that build output, we start a basic HTTP server to just serve it on our machine. And then we can open Lighthouse in the browser DevTools. And we go to the Lighthouse tab, and we can check the performance. So you can do that. I'm going to do it as well in parallel, so we can pretty much do it together. So let's get to that repo. So if you follow the URL I gave you, you would land on here. And there's a README toward the end, and that README shows you a link to my slides. So you can get the slides and even follow from here, and a link to the github.dev, so that's a GitHub code space, where we can check out everything and just have our own integrated IDE, so you don't have to download the code on your machine. So if you click on here, you would get to that sort of GitHub code space. And then I'm going to say continue working in GitHub code spaces right here, which is basically going to create that environment. OK, 2 cores, 8 gigs of RAM, that's good. And of course, it's a live demo, so it's bound to fail at some point. But I have a plan B, so don't worry. If things go wrong, we still have ways to make it work. So far, so good. It looks like I got the code. Everything seems to be set up here. So I'm just going to do npm install, which is the classic, get my dependencies in place, npm install. It's going to take a few seconds. And once we have that, we can build. So this is just a regular Angular app at this point. There is no, it's just a front-end application, no server-side stuff at all, which means that if we look at the code a little bit, just to give you an idea, the main page that we see is called store view. And we have a store view component that makes an HTTP request to a server and displays the products. So what we see here, these different license plates, they are products that come from a server. And the main component doing this is this store view component. So npm install is still happening. So once npm install is going to be done, I'm just going to build the project. So npm run build is going to be my next step. I can close this. OK, any key to exist. Looks like we are good here. So npm run build, which should be pretty fast. And it didn't find it. So let's go to my package JSON. There is the ng build in here. So I think I should be good. And this, of course, always worked before today. npm run build. OK, doesn't want to. No problem. So if we build that, we would get an output. And that output would be in the dist folder. We would have that index.html that looks like exactly what we saw right here. And then we would run this in a browser. And in that browser, what we would do is just go to the app. We would go to the DevTools. So you can just right-click, inspect, or go to the DevTools any way you want. And from here, you would go to the tab called Lighthouse. And we would do analyze page load. I would select performance in that category and just click that button. And this is going to render the app and give me a score. So I'm cheating a little bit here because that's not my local version. That's the one that's already on the web. So I'm getting a score, which is actually pretty good, 93. And we see that there are some of these metrics are in orange, mostly CLS, which stands for cumulative layout shift. And the reason why this is not great is because, as we mentioned earlier, our index.html by default is empty. So the first thing the browser sees is this white page with nothing on it. And then Angular loads, and Angular starts rendering stuff, and then we make those HTTP requests to get data, and then the images load and everything. So the layout of the page keeps changing, right, over time. It goes very quickly, but still there's a lot of layout, switching, moving around over time till everything is rendered. And that's why Lighthouse gives us a penalty for this, which is basically you're just switching things around too much, and from an SEO perspective, Google doesn't like this. And from a performance perspective, if you use that app on a slower device, like an old phone or that kind of thing, it would be a big problem as well. So yeah, that's basically the timeline of all of the different steps before we get the app fully rendered. So first it's blank, then there's a few components showing up, then there's more components and data coming from the server, and then the images load. So it's, yeah, it is slow, uses battery power if you're on an older phone. It would be even worse on a smaller screen, by the way, because there's a lot more layout adaptations to be made. The smaller the screen, the trickier it gets. So yeah, mobile devices do not like cumulative layout shift. So now we see what the problem is with regular Angular, right? Regular client-side rendering. Because we have to build everything step by step on the client side, our layout is going to move, things are going to be slower. If we use SSR instead, what's going on? Well, things are going to be a lot different because when you use SSR, you navigate to a web page and you download the HTML and the CSS, and the page is rendered. So all of the steps we had before, which is download JavaScript, load the Angular app, do all of these different things, now it happens right away, and our page is rendered right at step 2. Of course, our JavaScript still gets downloaded and parsed and interpreted and all of that, and then finally Angular is going to take over that DOM, which is a process that we call hydration, right? So the DOM that we got from a server, Angular is going to say, oh, OK, it's already there. Let's use that as the starting point, really, to keep this application running. So this is what we know as hydration. So this server-side rendering enables quite a few different things. Speed is the main one. It's the most obvious. Once you start using SSR, your app just loads instantly. So it looks like magic. And of course, there are scenarios where it makes a lot of sense to do that, because some of the components in your app always display the same thing. Like, they're pretty much a static web page. So why would you need complex JavaScript and HTTP requests and stuff to display that content and recreate it every time a client goes to your web page? So yeah, all of the static pages makes a lot of sense to use SSR. Search engine optimization, SEO, same thing, because these pages load faster. They don't have that layout shifting going on. Everything is there right away. So you get more points from an SEO perspective. So if you want to rank higher on Google, that's a good idea. And performance, which is basically the same thing as before. You'll get better scores in Lighthouse for everything. So contentful paint, cumulative layout shifts, and all of that, just because your DOM is built from the start. So how do we enable SSR? Now that we know about the why it would make sense to do this, speed, SEO, faster stuff going on, how to enable it. The good news is that it's never been easier to do SSR with Angular. We're just one command away of using it. So that's really super nice and easy. If you're starting a brand new project on Angular 17+, you can do ng-new-SSR, and this creates a brand new project for you, all set up for server-side rendering from scratch. You don't have to do anything. It's already going to be working with SSR and all of that stuff. So ng-new-SSR. If you have an existing project that is upgraded to Angular 17, then you can do ng-add at Angular/SSR. And the schematic is just going to do its thing to turn your code into a server-side rendered application. So we're going to do that. We're going to take a look at how this would work. And when you run that schematic, this is exactly what happens. So this is what Angular is going to change in your project structure to enable server-side rendering. A few new files get created, a main.server.ts, server.ts, and the config for that server. So basically, the files that contain the code for your server-side application. And it's going to update, of course, the Angular config, so that Angular knows that we have server-side going on right now. So tsconfig, package.json, just adding a couple extra commands to build the pre-rendered pages and all of that. And our app config gets updated. So that's pretty minimalistic, really. It doesn't change hundreds of files, just 3 new files get added, and some updates to our config. So one of these changes is going to be in our routing config, where the CLI is going to add this provide client hydration option. So it gets enabled by default. We don't have to change our code. Again, you could use your Angular app as is. Just run the ng-add at Angular SSR, and it's going to work, which is somewhat magic. I like it. When you just run one command, it works. It's always a good feeling. So we'll do just that now. We are going to take our old app and try to add Angular SSR. So let's go back here. npx ng-add at Angular/SSR. And if it doesn't work, I'm going to pretend that it did and move on to plan B. OK. So let's go here. So in this environment, it's already done. The migration happened. And so we have the file that I just talked about. The most important one is server.ts. And if I open it and zoom in a little bit, you see that it's an Express Node.js server that was automatically generated for you. And all of that code is available. And it would run on port 4000 by default. So that's a new server that gets generated. And if I go to package.json, which is right here, we have that new command to serve our project using SSR. And all it does is reuse Node.js to run our compiled server JavaScript code. And that's really the essence of what you can see in terms of changes in new files and new config that is important to know about. Now, in terms of behavior, we saw the files that have been updated and created. Now, if I compile that code, so if I do a build, npm run build, it is going to compile everything. Takes a few seconds. And now I can go to my dist folder. And the first difference you're going to notice there is that we have a browser folder and we have a server folder. So the server folder has pretty much the server-side file that we saw earlier with some extra config around it. And on the client side, now we have an index.html. But this one is very interesting to look at, because if I open that index.html, you can see that it's not the empty shell that we used to have. It's actually the entire landing page that was pre-rendered in here. So when we run a production build on an Angular SSR project, the output of that build is pre-rendered HTML already. So the server side just created the entire DOM and put all of that static HTML inside the output of my build. And it was smart enough to see that this application has 3 different routes. So it went through all of them. It was able to discover them and do the same process for each route. So you can see here that we have a cart and a checkout folder. And in these two, we also have an index.html, which also has the pre-rendered application for these other pages. So that's what I say. When I say it's almost magic, it just takes over your app, discover everything, and then generates all of that stuff for you. That's really as easy as it gets. And just to illustrate that I didn't change anything in my routing, let's open the route config. So that's what it is. There's just a default path, a cart path, and a checkout path. And the Angular SSR was able to see that and pre-render all of these pages with their corresponding index.html. So now I can serve that. I'm going to run, the longer command, npm run. I'm going to copy paste it. Serve SSR ngx training. And by doing so, I'm now running a server-side rendered Angular application on localhost 4000. So let's open it. You can see that everything is here right away. If I go to the cart page, it's almost empty, but it renders instantly. And if we inspect and do our other lighthouse tests, hopefully we're going to see an improvement. So let's do that. I'm going to, performance is checked. Analyze page load, suspense. %. That's good, right? So the only thing I did was ng add Angular SSR. That's really the extent of what I did to get my 99% score right here. So that's nice and easy. So of course, why do we get that score? Because the content, the cumulative layout shift is now almost perfect. Because when we download the HTML, everything's there. So the layout doesn't change anymore. Everything's down here right from the start, which makes things a lot easier. And yeah, we get nice scores out of the box. The other thing that's interesting to note with SSR, and that's an important distinction compared to a regular Angular app, is that if I refresh my page here, so see, I went to the network tab, and I focused on the XML HTTP requests, so all of the AJAX requests. And in the case of that page, there's one. That's the one I showed you earlier, the request that's going to get my license plate, this one, from the HTTP client. So this request should fire as soon as the app gets rendered to get the license plates and display them. Now if I go here and refresh my page, well, interestingly enough, there was no HTTP request. There was no AJAX request that we could see going on in the DevTools. And that's because what happens when we use a server-side rendered application is that Angular actually caches the result of the HTTP requests on the server side and transfers that state to the client, which means that this request here was run on the server side initially, And the result of that request was passed with our HTML to the client. So that when the client takes over, Angular is going to just run that code and use the cached response that it got from the server. So we don't see any HTTP request, right? It was already done on the server side, so there's no reason to redo it on the client side. We just use the same data. And so we don't see that HTTP request anymore, right? Nothing happened here. And if you wonder how that works, there's no magic to it, right? That data has to be somewhere, and we can see it. If I go to the HTML of my page and scroll to the very, very end, there's a script here that we can see. And if I open it, this script has an ID of ng-state, which is a pretty good name. And inside, that's the JSON data, that's the result of my HTTP request. So the data itself was passed as a script with my HTML page. And that's how the caching and the passing of that data did happen from server side to client side. So you don't even have to know about that, but just so you know, it actually happens and makes things a lot easier because we don't do the same work twice. Let's see. So we did a performance check with Lighthouse. We have that 99% score. Oh, in my earlier test, I managed to get a 100 at some point, but I tried multiple times. And just so you know, if you use Lighthouse on your projects and you use them on your own machine, the result depends on your internet connection, right? So if you're on a very fast connection, you will get a higher score. If you're on a very slow connection, you get a lower score. So it's not perfect from that perspective, but still gives you a good idea of possible results. So yeah, before we had something like 80% or more, and now we got to 99 or 100. Okay, so we saw that. Everything is pre-rendered. So I mentioned that everything happens automatically pretty much, and we don't have to change anything in our project. Is that always true, though? Is there anything we have to be aware of? Is there anything we have to do differently when we do SSR? So there are quite a few little things to know about, basically. But for the most part, our code remains exactly the same, meaning your components should be able to run as is without any modification using server-side rendering. The few exceptions are if you do things with window, document, navigator, location, HTML element. So if you're trying to mess with the DOM or the browser manually, in a sense, this cannot happen on the server side, right? There's no browser on the server side, so all of these objects are not available. So you cannot do that anymore, but there's a plan B. We'll see that there's an option to do so, and it was introduced in Angular 16.2. These are the two new lifecycle hooks, after render and after next render. So these two enable us to access these native browser APIs in the browser only. So it's just code that gets ignored by the server when we do server-side rendering. So here we have a quick example where our cart component wants to display the number of items we have in the cart. So it wants to display that in the title of the page using document.title. And what we do is that after the next render, which is really the first render in the browser, right? You can see that kind of like an ng on init on the client side, in a sense. So that's after next render, we set the document title to your cart empty. This is going to work with SSR because it doesn't run server side, only on the client side. And then what I do to make sure that my title is up to date with how many items I have in my cart is that after every render, so I use the other lifecycle hook after render, and I set the title to your cart item.length items. So it would refresh every time the component re-renders something on the client side again. So these two lifecycle hooks, they are available since Angular 16.2, and they have to be in the constructor of your component. So that's a little bit different from the other lifecycle hooks that we had before. So be aware of that. They go in the constructor. And yeah, that's basically how we can do things on the client side that won't happen on the server. So in the case of my app here, if I wanted, we saw that right now this HTTP request, it only happens on the server. And when we get to the browser, it doesn't run again. If I wanted to force another run and say, hey, you know what? When we get into the browser and everything's ready, let's just get that data again to make sure we're fully up to date. So if I wanted to do that, well, the recipe would be quite easy. I just add a constructor. In that constructor, I would do after next render, because we probably want to do that only once, not after every render. That would be an infinite loop, right? Because I get new data, I display it, triggers a new render, and then it just loops forever. And then I would just do this again. So I'm not going to do it the cleanest way possible, but just to give you an idea. I'm live coding on stage after all, so I can take some shortcuts. So I'm just doing that now. Tiny change, saving it. I'm going to rebuild and rerun this code, because I'm serving my build output right now. So let's rebuild. Suspense. There we go. Serve it again. All good. And now I can go back to where I was running this, which was right here. I can open the network tab, refresh, and this time I should be able to see an HTTP request somewhere. There we go. That's my request to data. That got the same list of license plates, but this one was triggered in the after next render. So by using these lifecycle hooks, you can decide things that you want to do on the server side or on the client side only, or both, right? That gives you that flexibility of deciding when and how to do these things. So the question is, the default behavior, yeah, as you say, the default behavior is that the data is going to be fetched from the server side, meaning the server is trying to render all of these routes by default. And if the components in their initialization make an HTTP request, then that HTTP request happens on the server side automatically and gets cached automatically for the browser to take over with that data. So yeah, all of that is a default behavior that happens out of the box without writing any additional code. Yeah. Yep. So if you don't want that to happen on the server side, what you can do is something similar to what I did here. So this would run as part of the creation of the component, right? The initialization of making that HTTP request. If I wanted this to not happen on the server side, I could command it out. So the server is not going to run that request, and it's only going to do it after the render on the client side. So that way you can control what's going to be server side, client side, or both. That's the easiest way to tweak it. Let's see. So we talked about server-side rendering. We talked about these new lifecycle hooks. Now, the last big portion I want to talk about is, because there's a lot of vocabulary with SSR-related technologies. You've probably heard about static site generation, or SSG, also known as pre-rendering sometimes. And what's the difference between that and server-side rendering? So that's the next thing I want to talk about. Because one thing that changed between our front-end, pure front-end Angular and our SSR Angular is that in the SSR mode, we need a Node.js server to serve that application, which was not the case before, right? In regular Angular, you can take your build output and put it on any sort of web server, and you're good to go. Now with SSR, you need Node.js. So you need some Node.js hosting to run that code and make it happen. And sometimes people want to do that, sometimes they don't. So it's just an extra constraint to be aware of. But if for some reason you cannot use Node, or you don't want to, or you think it's overkill, or whatever, you can use just pre-rendering in that case. And by using just pre-rendering, the idea is that we would only use the build output that happened when we did that ng-build earlier. So just use this static index HTML, and that would be it. There would not be any other SSR feature, just the pre-rendered pages that were built at build time. Now, of course, the big difference when we do this is that the initial state of your app, when it loads in the browser, is the state of your page, of your app at build time, which could have been maybe 2 months ago, right? Whereas when you use regular SSR, it's the live state of your app like a few seconds ago. So that's one of the things to be aware of. If you don't want to use Node, you can use pre-rendering, but then the state of your app is from back when you ran that ng-build, which could have been a long time ago, possibly. Can you say that again? Yes? Yeah. Yeah, so the npm run build we ran a few minutes ago, if I go to my index.html and scroll to the very end, see there's the script with the ng state and the JSON from that HTTP request. So it is in my pre-rendered static output. It's all in here, yeah. But of course, it would be most likely stale data 2 or 3 months from now, or maybe even minutes from now, because this is an e-commerce application. So maybe someone is going to buy that product in the next 5 minutes, and then, of course, the state of my pre-rendered pages is completely stale. So that's something to consider, something to be aware of. So yeah, the main difference, pages are built only once at compile time, not on the fly at runtime. And that SSG, so server static site generation option, is good for static content that you pretty much never update. So if you have a FAQ page or marketing landing pages or that kind of stuff that just text that rarely changes, or if you change it, you would have to basically rebuild the app. These are perfect candidates for that kind of static site generation, because it's going to be a lot faster to display them, and you don't have to worry about having a specific Node server. So yeah, that's always a good option. Can you say that again? Live reloading? Oh yeah, so everything I've done here was just using the static output and displaying. So by live reloading, you mean at dev time, right? Yeah. Yes, yeah. Oh yeah, so the live reloading, just your ng-serve still works, right? So you just use that command and you have the SSR up and running with the same ng-serve as before, and you have the live reloading, yep. So another thing that's going to happen pretty often when you start doing server-side rendering. Oh, yeah, you go ahead with your question first. So you mean, does it go in depth at looking at the internal links of your app to pre-render other things? I'm not sure I get you. Can you get closer or speak louder? Yep. Mm-hmm. OK, now I got your question 100%. So when you do SSG, the answer lies into those index HTML that gets generated, right? So as we saw, there is one index HTML for each route that Angular discovered through your routing config. So here I have one for my checkout page. I have one for the cart page, which means that the links between those pages are regular links, and then would load those HTML pages, which are fully rendered, and then Angular takes over, hydration takes over, and if there's any updates from your Angular JavaScript code, new HTTP requests and such, it would just refresh the contents. So that when you do static site generation, and you have Angular components and HTTP requests and everything, the benefit of SSG is to have your initial state pre-rendered and displayed right away. And then right after that is done, your Angular app is just a regular Angular application, right? Nothing changes from that point on. So it's just all about pre-rendering stuff. So you don't have to start from scratch on the client side. That's really the idea. And because of that, because we saw that this SSR, SSG is based on our routing config, the routing config doesn't say everything about our app. There could be thousands of different routes, especially if you have parameters, right? For instance, maybe we have a product/ID route somewhere, and maybe we want to also pre-render some of those because we know they're going to be popular, and we want to make sure that we pre-cache those things. So there's an option for that. We can specify some routes and tell Angular, hey, you know what? Instead of trying to guess what to pre-render, I'm going to give you a list of all of the URLs I want you to pre-render on the server side. And we're going to see how to see that very soon. Or you can use that same list to do it the other way around and decide that only some pages get pre-rendered up front and not the entire thing. So that list can be used one way or the other, really. So when we, in the config of our server-side rendering in Angular.json, there's a bunch of options that are interesting. The first one is true by default, and that's discover routes. So that's the option that says, go to my route config and discover everything I have so I can pre-render it on the server side. So discover routes is true by default. If you want to take over, really, and say what has to be pre-rendered, you would make that false. And the second option that's interesting is the routes file, where you can tell Angular where to find the list of these routes that you want to get pre-rendered. So we'll see how to do that. There it is. That's an example. So if I want to enable custom pre-rendering, this is my Angular.json. In that Angular.json config, you would have to find out the section where you have the server config with SSR and everything, and that pre-render option. You would make it discover routes false, and the routes file would go to, you can name it anything you want. I name it routes to pre-render.txt in here, and that routes to pre-render.txt says just the landing page and the cart page. So you could decide to have more or less, up to you. And let's do that now. So we're going to test two things in that step. We are going to test SSG instead of SSR, which means that the command we are going to run, instead of running a Node.js server, I'm just going to run a basic HTTP server that doesn't know anything about Node.js. So that's the main difference we're going to have here. So let's do that. I go back here. I kill my server. Do I need to rebuild? I don't think so. We didn't change anything, so I guess I'm good with just the static option. And this command that I'm about to run here is something I added myself. Didn't come from the Angular schematic. It's just a shortcut to run an HTTP server in dist ng-external/browser. So instead of typing this, I created a specific command, which I'm going to run right here. So this static server runs on port 8080, just so we know that it's something different. Also renders instantly, right? That's my pre-rendered state. And so the lighthouse score would be as high as the previous one, hopefully, because it's really just the same thing. Let's go and give it a shot. So we're expecting at least 99. Yes. So that's pretty good. And again, I'm not using Node anymore. No SSR, just SSG. So just a static output of our builds and a regular basic HTTP server to serve that code. So you can get the benefits of the pre-rendering without changing your infrastructure if you don't want to use Node.js. That's important to know about. Yep.
When you think of SJS, right, Watson does a pretty good job of like, if you want to do SSD, or if you want to do SSR, and if you want to do SSD also at a regular interval, like every 1 hour or something like that, right? Watson will enable you with those options. What are some of the options if I want to do similar thing in Angular SSR mode?
So you mean comparing to what Next.js does?
Not comparing. If I want to do SSD and SSR, right, basically. For a typical application, my product's path might be SSD, and some other path might be SSR, right?
Yeah.
How do I achieve those things? Where do I host? How do I host them, basically?
So one of the places where this is going to happen, so when to pre-render or not, is going to be that, that option that I mentioned here. No, not this one. So you can use that to decide what to pre-render, what not to pre-render, right? That's one thing. So that way you can really have more control over what's fully client-side, what's server-side, where to do SSG, no SSG, that kind of thing. There are other options to fine-tune this even further in the documentation. And as the Angular team mentioned this morning, they're working on, what's called partial hydration, which is even more control over basically pushing this to the next step where it's not black or white, like server-side or client-side, but kind of in between. Like you can pre-render some of the components on the server-side, but then when you start interacting with it, it's going to load all the other stuff. So there's very much a lot of work in progress on that to really push it to the next step and give us even more options, even more control. But what I like about this is the simplicity of the approach. We spend like 45, 50 minutes working on this, and you have probably 90, 95% of the knowledge you need to start doing SSR like right now. So that's very important. The simplicity of the API, just running one Angular CLI command, all of that stuff is very important. What I have next is a Q&A. Any other questions, anything you want to ask about? I'm available. And if you don't want to do it now, I'll be at a conference later today and tomorrow as well. So feel free to come find me anywhere, anytime. Always happy to help and answer any questions. SSR or not, by the way. SSR is just one of the things I talk about, but I can talk about anything Angular. So yeah, any questions you have, I'm always happy to answer. So it would just render it on the server side, right? So at the point of time when the server side is rendering your ng-if, if the value is true, then it just creates that HTML. If the value is false, it just doesn't create it.
So like in the case of HTTP call, and it's not rendered until that call finishes, would it show the spitter, or would it show what point does it? Because there's different steps, right? I have a spitter, and then I show the actual thing of like rather than making it server renderer now. Is that something I need to update?
So yeah, I guess the easiest way to see it is that the server side is really all about it's just doing the same thing as the client side. There's no difference. When you do the pre-rendering, it's doing it at build time. So at that build time, it's going to make the request, get the data, run those ng-if and ng-for and everything, and based on the data that you have at that point in time, create the DOM structure that goes behind it. And then when that code gets to the client side, Angular takes over, reuses those elements with hydration to update with whatever new data we have, and does its best to do what is called a non-destructive hydration, meaning not reinventing HTML elements that are already there, that have already been downloaded and everything, which was not the case in the past. In the past, everything would just be completely recreated. So you would download the entire DOM, Angular would load and just destroy it and rebuild it. Now it's super smart. It's trying to figure out, hey, we already have this, so we use it. If it's there, we just use that DOM, and relying on compiler techniques to figure out which DOM element is linked to which directive or control in our components. So yeah, the heavy lifting has been done for us, which is really nice. Any other questions?
Sorry, one more question.
Yes.
You said this is the first 117. This one's being able to use the NG update and SSR. What are the differences between 16 and 17 previous versions?
So the hydration stuff, the ng-add at Angular SSR, I think became available with v17. So if you want an easy migration, everything, nice and easy, v17 does that for you. Some of the features we talked about, like the after next render and all of those, were introduced a little bit earlier in 16.2. But yeah, getting to v17 is how you'll get the. I mean, it's always good to use the latest version of Angular anyway, so I'm not going to say try to use an older version. my advice would always be get to the latest no matter what. Yeah. So there's 3 minutes left. If you have any other questions, feel free to let me know. Just a couple of other things I wanted to talk about. If you want to showcase your Angular skills and looking for extra ways to showcase your expertise, so Angular training, we're running an Angular certification program, which is run almost exclusively by GDEs or NG champions or friends of the Angular community who are really good in Angular. And so it's an exam. You take that online and you receive a certificate which showcases your skills. One of the things that's unique about it is that for the intermediate and the expert level, you get to do an interview as the final step. And that interview is done with one of the GDEs or NG champions that are part of the team, including myself. So I know that's something people like a lot, the fact that they can interact with the GDE and get feedback on their code. So just so you know, that's one thing that we do. And here are all of the links. So everything we talked about, bit.ly AT-SSR workshop is a link to my slides. There's a QR code here to the 3 monthly Angular workshops that we run as well. Next one is about RxJS, early April. So if you want to learn more about RxJS, and it's completely free to attend. It's a similar format to what we did here, 1 hour, 2 hours on one specific topic. And yeah, that's everything I had. Again, if you have any questions, anything, feel free to come find me. And thanks for attending today. Thank you.